We will begin our discussion by looking at the straight line. First, we will look at deriving the equation of the straight line using two coordinates. We will then look at deriving the equation of the straight line from a set of coordinates as well as the gradient. We will then move more into the gradient. First, we are going to get the equation of the straight line from two coordinates. I'm going to use coordinates A, which is 5 and 4, and coordinates B, which is -2 and 5. And I'm going to get the equation of that straight line. Now let's just draw that out just to see what sort of straight line we're looking at. A's coordinates is x is equal to +5, y is equal to +4, so it's going to be over there. B is x is equal to -2, y is equal to +5. So that's going to be somewhere over there. Alright, so we're looking at that graph over there, or that straight line rather. That's B and that's A. To get the equation of a straight line using two coordinates, I'm going to start off by saying y is equal to mx plus c. Now this is the standard equation of our straight line. The next thing I'm going to do is I'm going to get my m value. Now a golden rule about straight lines is that we are very concerned about the gradient. Obviously we're concerned about everything else, but the gradient is usually our starting point. The gradient tells us a lot about our graph. The gradient in this case is going to be y2 minus y1 over x2 minus x1, which is equal to y2 minus y1, 5 minus 4, over x2 minus x1, which is -2 minus 5, which is going to give us a gradient of 5 minus 4 is 1, -2 minus 5 is equal to -7. That means that our gradient is -1/7 or 1/-7, it's the same thing. That means that y is equal to -1/7 x plus c. Notice I went back to that form, except I now have m. Y and x are fine. In a straight line we are alright with having y and x. The problem is c. We want c to be a value, to be a number, as opposed to just a variable. In order to solve for that, I'm going to substitute any point in. Now I'm going to substitute both points in, and I'm going to show you that it's going to give the same answer. First, let's substitute a in black. Instead of y, we're going to put 4. 4 is equal to -1/7. X is 5 plus c. That means that c is equal to, now all I'm doing is keeping c on this side, taking everything across to the other side, but I'm flipping it. So that's going to be 4 plus, because that will become positive, plus 5/7. 1/7 times 5 is 5/7. Problem is, this is 4/1 plus 5/7. That's the same as 28/7. I just multiplied it by 7. 4 times 7 is 28, plus 5/7, which is equal to 28 plus 5 is equal to 33/7, positive. That means that my equation now reads y is equal to -1/7x plus c, but instead of c it's plus 33/7. If you want to neaten this out, you can say 7y is equal to -x plus 33, but there's no need to do that. You can leave it in this form. That means that this point here, the c value, or the y-intercept rather, is going to be at positive 33/7, and an x value of 0. And its gradient is negative sloping, -1/7. Now that's substituting point A in, which I did in black. I'm going to show you that point B will give us the same answer You don't need to substitute both points in though. I've got y is equal to negative 1 over 7x plus c. I'm now going to substitute 5 in place of y is equal to negative 1 over 7 multiplied by negative 2 plus c. That means that c is equal to 5 minus, because minus times a minus is positive, take it to the other side is going to make it negative 2 over 7. Again, that's over 1, so I've got to simplify it. That's going to become 5 times 7 is 35 over 7 minus 2 over 7, which is equal to 33 over 7, which is going to lead to the same equation. Now we are going to look at coming to the equation of a straight line using a gradient and a set of coordinates. In this case, the gradient I'm going to use is negative 5, and the set of coordinates I'm going to use is 2 and negative 8. Not a difficult one to do. In fact, this is even easier than the previous example, because in the previous example we used our 2 coordinates to get the gradient. That means that our equation reads from the start y is equal to negative 5m x plus c. To get c, I'm going to substitute any point that I have. I've only got 1 point, so I can only substitute that point in. Minus 8 is equal to negative 5 times 2 plus c, means that c is equal to minus 8. Negative 5 times 2 is positive 10. Negative 10, sorry, taken across becomes positive 10. That means that c is equal to positive 2. That means that y is equal to negative 5x plus 2. Which means that our graph is going to be very negatively sloping, very steeply sloping, and it's going to cut the y-axis at positive 2. I'm not going to fill in any more information about that. That's just to show you what that graph would more or less look like. Also, we know that it's passing through the point x is equal to 2, y is equal to negative 8. So that's going to be negative 8 and possibly 2. Something like that. The big thing you need to note is that if we had our gradient, we just needed 1 point to get our c value. Once we got our c value, we went back to the standard equation. Now let us take a quick look at moving from the equation of a straight line onto the coordinates. I'm going to use the example y is equals to 3x minus 4. Sketched on a graph, it looks like this. If I need to move to any set of coordinates, I am going to have to plug in the corresponding values. For instance, if I'm looking for the y value when the x value is equals to 5, how will I do that? It is actually quite an easy one. All I'll do is I'll substitute that x value of 5 into my equation y is equals to 3x minus 4. That means that my corresponding y value will be equal to 3 times 5 minus 4, which is 15 minus 4, which is equals to 11. In most forms of analytical geometry, the easy way of getting the corresponding coordinate is always to just plug in the value that we do have into the formula. I want you to have a go at the following examples. Press pause on your DVD player, and when you return we'll go through it together. And I told you that we have an x value of 2. What is the corresponding y value? Now in order to do this, it's actually quite easy. All we're going to do is substitute this x is equal to 2 in.